now our formulas are all balanced. And the rule is, once the formulas are balanced, leave them alone. Don't change any of the subscripts now. What you can use now, the only thing we can use now to balance the equation is a coefficient, or any number of coefficients if we need them. So let's list all of our atoms. This is where we do the atom inventory. We've got lead, got nitrogen, oxygen, sodium, and iodine. We're going to make our grid for the atom inventory. And we're going to count all the elements. We've got 1 lead. This 2 outside the parentheses, we already said, means there are 2 of the things inside. So if the nitrate has 1 nitrogen and 3 oxygens, the number of nitrogens we have, since we have 2 nitrates, is 2. The number of oxygens is 6. The number of sodiums right now, 1. The number of iodines, 1. Okay? Over here on this side, we've got 1 lead. We've got, let's see, nitrogen. We've got 1 nitrogen. We've got 3 oxygens, 1 nitrogen, and 2 iodines. We want to try to get all these numbers to be the same, and what we're going to use to do that are the coefficients in the equation. Remember, we're saving oxygen for last, and if we had one, we'd save hydrogen for next to last. Did I risk nitrogen? Oh, I'm sorry, there should be sodium here. 1 here and 1 there. Okay. So we don't have a hydrogen, so we're going to save oxygen for last. Let's start with nitrogen. I have 2 on this side. The only thing we can do to get more nitrogens on the right side is to use coefficients in front of the formulas. That's going to change the number of all these elements here. It's going to change the number of sodiums. Instead of 1 sodium, I now have 2 sodiums. Instead of 1 nitrogen, I now have 2 nitrogens. Instead of 3 oxygens, I now have 2 times 3, or 6 oxygens. All right. Now we've got to go back and balance a few more things. It turns out that fixed our oxygen problem, but it unbalanced the sodiums and iodines. Well, that's an easy one. 2 sodiums on this side, 2 iodines on this side. If I put a coefficient of 2 in front of sodium iodide, I'm going to have 2 sodiums and 2 iodines, and the equation's balanced. Okay, so I know we've balanced equations before. The main thing I want you to get out of this is how to predict products in a double replacement reaction. Recognize there are 2 two-part compounds. Switch out the parts. Notice the front part stays front. Front part here stays on the front. Back part stay on the back. Back part on the back. That's because positive ions are always listed first, and if we figure out the charges, as we did down here for some of these things, we can see that the positive parts of these are on the front. Figure out the products. Figure out if you have a driving force. Driving force in an aqueous environment is the formation of a solid or the formation of water. There's also the driving force, the formation of a gas. We won't be using any of those in this class. So that's our example number 1 for figuring out what the driving force is and whether you have a reaction, and then, of course, reviewing balancing equations.